The name node manages the metadata while the data node stores the actual data.
That's perfect. That's perfect. So the name node will just save the uh, the metadata, which means we're going to have address, so basically where in which directory uh, the files are saved, the security of the file, that information. But the file itself is saved into the data node. All right. And how do we call the whole system? So basically, name, code, data node. The way the data are saved. How do we call it? So if we have to look at a group of information about one data, so how do we call it? So basically putting together the name code, so all the information about those data, name code, data node, name node, data node. So how do we call the whole a group of data, a group of information about the data? I'm not sure if my question is clear. So you will hear about the term a cluster. So when we talk about a cluster, so a cluster is so basically we can say the way data are saved. So data are saved in clusters. Okay, so you can hear that term as we moving along. We can use the term cluster, so you'll understand we're talking about the group that is formed. Okay, so remember what we'll have in the name code. We'll have the namespace, which will contain the directory, files, and blocks. Okay, so this we mentioned them yesterday. Okay. Okay, so very important to note this. Remember, I just mentioned the cluster. So the cluster is a whole group. So when you're looking at cluster, right? So once we are in a cluster and then we just have an issue with the name code. Once the name code has an issue, once the name code is faulty, you need to note that the entire cluster becomes unavailable. Okay, so things like this, statements like this, will be very important when you have like question like true or false questions. Because when you have true or false question, they may give you these statements. They say true or false in maybe in the architecture of an HDFA. They will tell you that once only the name code is faulty, the entire cluster becomes unavailable. Right? So why is this important? This is important because remember yesterday we mentioned the fact that apart from the HDFA 3.0, the previous version of HDFA will have in the whole structure, in the whole architecture, we only have one name code. Okay, so we only have one name code, the single name code, and then we have multiple data. Why am I saying name code? Name nodes, and then we have multiple data nodes. So the issue now here, once this name node is faulty, it means the entire cluster will become unavailable. Because how do you access any data if there's a problem? And so that's the problem. That's the disadvantage of having a single name code. But if we have multiple, the data can still be found using the other name code. Okay. Um, and we also mentioned the type of command that are used to access data. So once you want to display the file content, you use the cat. So we spoke about that yesterday. So mentioned how to write and how to read, how the process happen. Okay, so today we're going to start with Zookeeper. So Zookeeper is another software as well, which is still provided by Apache. So Apache is still so we have another program which is called Zookeeper, right? So Zookeeper, what is Zookeeper? This is very important. So Zookeeper is another program which is very important as well in this, especially when it comes to security. Why? When it comes to security, sometimes you have a very big organization, an organization like Twitter, Facebook, for example. They can't keep all the servers in one location. You keep all the servers in one location. Imagine such a big company, you're keeping all the servers. Let's think of an organization like the Department of Home Affairs. The Department of Home Affairs have the information of the whole country, 54 million people. Now imagine if the servers are in one location, somewhere in Durban or somewhere in Pretoria or Johannesburg, right? And now that location, there is fire and all the servers burn. So can you see the amount of data that will be lost? So what companies and organizations do is that they have multiple locations of servers, and other locations are used as backup. In case there's a problem in one location, we can still access the other location. So now the Zookeeper, that's why it's called Zookeeper. So Zookeeper is a system that helps you manage all those servers, helps you manage how your data are linked through those servers. Okay, so what is Zookeeper? So basically, Zookeeper is just a distributed service framework, right? So Zookeeper is a distributed service framework which is used to solve some data management problems that are frequently encountered in distributed applications, right? I've mentioned here you can have issues with security, you can have issues with power, there's load shedding, and then the whole system is offline. Why? Because all your data are saved in servers in one location. So when we look at Zookeeper, so basically Zookeeper will help us manage things like configuration. We have the configuration of our data. How do we get our data across different systems? So all those things are managed by Zookeeper. So Zookeeper will really help maintain that consistency or reliability in distributed applications such as Hadoop, right? We're using it Hadoop HDFS, which is a distributed application system, right? Where the data are in different locations. So when we can to help us maintain the consistency and reliability of our application, so we're going to use Zookeeper. All right. So basically, when you look at Zookeeper, Zookeeper is like a network of multiple computers, right, which are working together to achieve one common goal. All right. So when you look at how HDFS is, remember we spoke about the data nodes. So when you look at the data nodes, you can see now we have multiple data nodes. Imagine we have 1,000 data nodes saving data. Remember we mentioned that in a data node we can have maybe 128 megabytes of data. Now imagine we have terabytes of data about the organization. They are distributed in different data nodes. How do we make sure they are all working together? How do we make sure we maintain that consistency in terms of how the security, how the data are being managed and everything? So how we make sure that we can synchronize all the data, okay, between the nodes. So that is what Zookeeper is going to do. So Zookeeper is just a distributed system service that can help us manage that. All right. So and another thing as well, Zookeeper will really help us just to coordinate the whole service in terms of managing and synchronizing distributed applications such as Hadoop. Okay, so we have a few features, right? Few features in Zookeeper which we're going to mention, right? We spoke about security, right? So in security, Zookeeper will really help us get maybe different authentication of password and all those things. Okay, so it's really consistent. It helps us to collect all the data and make sure all the data are arranged properly. Okay, so uh, one thing about Zookeeper is even if some of the nodes, remember, yeah, we're dealing with many nodes, so we have data nodes everywhere. So imagine if some data nodes have issues, some data are corrupt. Zookeeper will help report those issues so that the whole system keeps working. So the whole cluster will work properly because we are using an external service such as Zookeeper. Okay. Okay. So this is in terms of the architecture of Zookeeper. So Zookeeper will have when we look at this, we can call it a Zookeeper cluster. Okay, so this can be a model. So a Zookeeper cluster consists of a group of servers, right? So we have all these servers, server 1, 2, 3, 4, 5, whatever amount of servers you can have. So basically, a group of Zookeeper servers, usually they usually use some odd numbers, right? Like 3 servers, 5, 7, 9, 11, So basically what happened is that now we have all these servers. We can have 7 servers, but there is one server that will be what we call the leader server. So this leader server will be the one that will handle all write requests. So remember we mentioned with HDFS, we say we can write data. So writing data means modifying data or adding data to your data system. So when we're dealing with that, it's only one server that will be dealing with the write request. Okay. And now the rest of the servers are what we're going to call the followers. Okay. So when you are starting the servers, one server will be elected during the startup. Okay. So basically what will happen with the leader, so when you receive, for example, a data change request, the leader node writes the data to the disk and then to the memory. So one node will play the role of being the leader and the rest will just be the followers. Okay, so the followers will get requests such as read requests. When you're requesting to read the data, that request can be handled by a follower. Uh, and then what will happen is that the request will be done by the follower, and then the follower will sync that request to the leader. So all information should also pass through the leader. That's why they call leader and followers. Okay. So remember, in a Zookeeper cluster, the leader will handle the write request, and the followers will handle the read request, but they will handle the read request and synchronize it with the leader. All right. So that's why the nodes are called, the nodes in the Zookeeper, they are called the Z nodes, right? Or Z nodes. Okay. All right. So this is the Zookeeper service architecture. So if we have we have what we call a service election, right? So when we say the leader is elected on startup, right? So now we have a leader that is elected on startup. So what happened is that during Zookeeper election, if we have depending on how the data will be, and depending on the numbers of servers, right? There is what they call a zookeeper election to elect a leader. So how does that work? It works in a way where we will see which server can be able to handle more requests, and that server will be elected as the uh, zookeeper leader, and the rest will be followers. Okay, so these are key features of the zookeeper. Okay, so we can really the data, there's a very high consistency. So basically, all nodes see the same data. Okay, so this is one of the most important things. So basically, we can say all servers are displayed in the same view, so they all have access to the same data, and then there is a real-time capability. So when remember yesterday we talked about client, right? So what is the client? The client is a part of the system that gives you access to handle the system. So basically, when you're dealing with a client, no matter what client you logged in with, or from whatever client you 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 logged in, so all clients can obtain all the servers updates and failures. Okay. And then we also, one of the key features, we have also the reliability. Okay, we have the reliability, which means a message will be received by all servers. So if there's any issue, let's say for example something changed in your server, or maybe you have an issue with some data, so all those messages are sent back to the server, and the server can get a report on the errors. Okay? So we have a wait free, which means a faulty client cannot intervene the request of a rapid client, so that the request of each client can be processed effectively. So even if we have one client, we have one issue, it's not going to affect the whole process. The rest of the system will work perfectly. Okay. So and then we have the atomicity, and then we have the sequence consistency. Okay. So basically, with the system sequence consistency, so basically all updates are sent by clients, and we apply them in a sequence in which they were sent. So if there is a first a request that have been sent, that request will be processed first. So if let's say you want to read, one client wants to read, another one wants to write the file. So the requests are done in a certain sequence. All right. So I'll give you an example. For example, you are on your computer, you have Microsoft Word open, you have Microsoft Excel open, you have so many apps open. And then at the same time, you go here, you click for something, you click for something, you click for something. Sometimes you see the computer become slow because now there is so many requests. So now, in the Zookeeper system, what happens is that when you have multiple requests attached, it's going to put them in a certain order so that the requests are processed in the order in which they were received. So the first request done will be processed first, and then the second one, the third one. All right. So the advantage with Zookeeper as well is that everything, all the operations are really optimized for read-heavy workload. So that means that it doesn't matter how many data you have, and you can handle multiple data. So this is one of the advantages as well. Okay, so according to the consistency of Zookeeper, remember we said all the nodes see the same data. So all the clients will view the same data. Doesn't matter how many data you have. So if you want to read, you make a request. You can read from here. You can read from here. You can read from here. You get the response. Okay. All right. So the write function. How will the write function be done? If you want to write, you can write to any local storage. So the request is sent wherever the data is found, and then we're going to write through that. Okay. Okay. So you need to note that the way all these Z nodes will keep the data, and all the data will just remain the way they are until they are maybe deleted. Okay, uh, that's one thing that you need to note about the data input data. Okay, so basically all clients will be connected to the server. So if a write request is made, for example, it is first forwarded to the leader, remember, and then the leader ensure that the change uh, is done to all the nodes wherever the change has to be done. So once it's confirmed, the change is applied, and then the response will be sent back to the client. So the client gets back a notification that the whole process is complete. Okay. And for read request, the server, any server can respond immediately. Remember, but for the write request, remember it has to go through the leader. But for the read, any server can respond. Yeah. Okay. So if you want to create a node, for example, when we in Zookeeper client, so we're gonna run the following command. So this following command will go and find with its IP address. It's going to find exactly where, in what node, in what where you want to log in and everything. So basically, this is the client server, so it connects to the right server at which you want to make a request. Okay, so this is how you can create a node. This is the command to create a node. To see the list of sub nodes, you can use this one. To create the node state, we have that. To obtain the node data, we have that. To delete the node, we have that. And to delete all node and sub node, we have this command here. All right. So just to summarize this, we can say that when we have the distributed file system is effective solution for large scale data. Okay. And then we have open source systems such as HDFS for the Hadoop distributed file system. And we also have the what you call this. We have the Zookeeper as well. So the system, and then we can say that HDFS is compatible with inexpensive hardware devices. Okay, for example, it is suitable with low latency data access. Okay, and then in terms of blocks, in the HDFS, the large file are split into multiple blocks. Remember that. So we'll have multiple blocks that we call rack. So we have rack 1, rack 2, rack 3. So we have all those multiple blocks. Okay. Okay. So all right. So and then we have a question. Okay. Can anybody tell us why do you think Zookeeper servers are deployed in an odd number? The numbers of Zookeeper servers are in odd number. The numbers of servers. Why do you think it has to be like that? Why are they deployed in odd numbers? Why? Why? Anyone can give us a anyone? Anyone? There's no one who can trust. Why do we need odd numbers? Why do we need 3 servers, 5, 7, 9? Why not 4 servers? Why not? Uh, you can unmute yourself and tell us. Anyone want to give it a try? Anyone? Guys, so there's no one who can give it a try.
Hi everyone. So, uh, like, okay, I think that it helps with okay, so having odd node numbers, right? It helps with like the decision making. It makes it easier for Zookeeper to actually coordinate data in a, yeah, how can I say this? Sorry, I don't have my answer straight for now, but it helps with like coordinating data, making sure that it makes a perfect decisions. Yes.
Yeah, yeah. You are on the right path. You are on the right path. Your idea is good. Uh, because okay, here's what happened. If we have remember what's happening. Why we have those servers? What will happen? Remember, we say all the servers access the same data. So they work with the voting. Remember, um, we spoke about elections, right? So if we have the leader getting a right request, and then we have the followers, so all the servers are acknowledging that process. Now, if we have the same number, we have an even number. We may have a voting where we had 4 servers, 2 reject that request, 2 accept the request. That's the problem now. So that's why we need an odd number so that we always take the majority. So there will always be, we will not have a situation where we have a tie. I don't know. Do you get it? Does everyone understand? Everybody understand?
No, sir, I did not understand.
Okay, so I'm gonna go back to the slide. Okay, so here is uh here is where we are, right? So when we dealing with write request, for example, so if we if you trying to write to add data, remember all the servers get the request, but one needs to be the leader on startup. One needs to be the leader, and the rest need to be followers. So the formula is n to x plus 1. So it can be any number, right? So now what will happen is that now we have all these servers here. So if we have 5 servers like this, one of them needs to be the leader so it can handle the request. Because remember, for all the requests that have to do with writing, so this request has to be done by the leader. So now, if we're looking for the leader here, now if the vote goes like this server here, acknowledge, this one acknowledge, this one acknowledge, so we have the majority already. So we will always have a majority if we have an odd number. But if we have an even number, what will happen is that we may have the request, but in the request that we have, there is 2 in favor, and then there is 1 that there's other 2 that are not in favor. So that would be a problem now. I don't know if you understand what I'm trying to say.
I'm okay now, sir. Thank you.
Yeah. So basically, when you are writing, for example, you modify a file in your system, these servers need to acknowledge, send back to the client a request that they need to acknowledge the change. They need to confirm the change. So if you have 5 servers, at least if 1 confirm the change, 4 do not confirm the change is not going to be done because the majority did not confirm. See, but if you have an even number, what can happen is 2 can confirm, 2 do not confirm, and that gives you a problem. You understand? So that's why we need an odd number. Okay. Anyone still confused there? Okay. So the other question would be, why is HDFS data block size larger than the disk block size? Okay, when you look at the disk block size, usually even from your computer, just to save, for example, in Linux, you just save the name of a file or something like that. It's about 4 kilobytes. Okay, but in HDFS, we mentioned that we go up to 128 megabytes. Why is the block in HDFS larger? Yes. So in this case here, we talk about, remember we mentioned the name code, the name node, I mean. Remember the name node in this case, we really need to store more data. Because remember the name node is storing the name of the file, the location, the security. So it's saving a lot of information about the file. That's why the blocks have to be larger. Okay, because if it's not larger, then it's going to use a lot of RAM, random access memory of whatever device you're using. So it has to use more memory. So this is the reason why the blocks are larger. They are larger because they have to save more information about the data. Okay. All right. So, and then the third one is, can HDFS data be read when it is written? What do you think? Can we at the same time read the data when it's being written? Guys, we've mentioned it. Guys, this one, I think everyone needs to be able to say. Can HDFS data be read when it is written? So when it's being written, can the file be read? Anybody? Guys? Anyone want to? This is a yes or no question, guys.
Yes,
It's a no.
it's a yes for
Okay.
me.
It's
It's
a
a
no
yes
for
for
me.
you.
It's a yes for me.
Okay, so we have how many people are saying yes? How many people are saying yes? Okay, I can see 3 people saying yes. Anybody else saying yes? Okay. How many people are saying no? No, I can see no, no. Okay, guys. The simple answer is no. Why not? Remember, I told you there is a sequence that needs to happen. So, and remember when we talked about the read and write, we spoke about the whole process. There is a process to read the data and then to write the data. Remember the file when it's being written. So this is when the file is being written. The file will be written, the whole process of writing a file, and then the file has to close. So we close the file. And then when we read, we have to open the file, then read the information in the file. So if the file is still being written, there's no way the file can be read. And remember, we said the whole process happened in sequence. It just happened faster, but it happened in sequence. So whatever request, so if you've already made a write request, the read request has to wait for the write request to be completed. All right, guys? Is that clear?
Yes,
All right.
sir.
So, yeah. So please note that the competition will have different parts of. So we're gonna have, I said it yesterday, we're gonna have big data. We're going to have AI and cloud computing. So we're going to go through all those, but it's very important for you to to be certified for all these modules. So basically, you will need to get a certification for big data, for cloud computing, and um, for AI. And guys, you must remember these certifications are internationally recognized. So this is bigger. This is something really bigger. All right. So that will be all about Zookeeper. Just what I just want to try and say something about the competition. Okay. So can you guys see the page about the competition? Do you guys see that?
Yes, we see it.
Yeah. So this is an example, and this was for last year, just to show you how was the competition going to be. So this will be written exams with a total score of 1,000, right? Numbers of questions. You have the type of question. You have true or false type of question. You have single answer question. So when we say single answer, it means maybe you are given multiple choices, but there's only one real answer. So it's very important when you're doing your exam to see what it says. If it says single answer question, it means you select one. If it says multiple answer question, it means there may be two of the options may be the right answer. Do you guys understand the difference? Is there anyone who doesn't understand the difference between a single answer question and a multiple answer question? Anyone? Anyone who wants any clarification on that? Okay. So I will also remember last time I sent a link and say there will be that's to access the cloud where we're going to be posting certain information. So I will save this on the cloud so you can access it whenever and you can download it. All right. So this is very important for you to know. The single question. So a mistake that other people do is they are answering a multiple answer question, but they are choosing one answer. You understand? While it was multiple, and then you end up failing. So you must know that. So that's the three types of questions that you're gonna have: single answer question, multiple answer question, and true or false. So that's what you're going to have. Okay, so these exams are just going to be like 90 or 60 minutes. Okay. And then the last one, which would at the global stage, will be the lab, where you're gonna have really have to understand how to practice this, how to show this in practice. Okay. So basically, when we talk about the preliminary stage, and then we have the national stage, so you're competing against people in South Africa, regional stage, people in Africa, and then global stage is obviously everyone around the globe. Okay, so how is this going to work? So on big data, for the preliminary stage, it's going to take 20%. So 20% will be big data, and then we're going to have 40% cloud, 40% AI. National, same thing. And then regional, we're going to have cloud 45%, big data 15%, AI 40%. And then global, we have 45% cloud, 40% AI, and 15% big data. All right. So, so the type of knowledge to be tested on, these are the type of knowledge to be tested on. So when we go through these sections, then we're gonna come back here and see. Okay. Okay. So when it comes to big data, this is what you will need to know. You will need to know the basic concept of big data. So all these are in your notes. That's why I said, guys, you've already registered, you've already approved. Start going through the videos and the notes, because this will be your exam. So once you pass this exam, you are good for the competition. All right, guys. Any question before we call it a day?
So I have a question concerning the exam.
Okay.
So, say someone applied for an exam slip, not this year, some time back, and
Okay.
that exam slip, it expired before they could write. Are they able to write? Are they able to apply for another exam slip and then write?
Yeah. You're gonna be given. Are you talking about the vouchers?
Yes, sir.
Yes. Yes. As long as you registered for the class, you've been approved. You're gonna be given vouchers.
Oh, okay. Thank you, sir.
Yeah. So everyone in the class will have access to the exam. All right, guys. Any other questions?
So, sir, is 2025 competition open or not yet?
Yeah. Yeah, it is open. This is why we're having these classes.
When I'm trying to register, I don't see that option.
Yeah, no. You need to register for these classes, and then we're gonna guide you through it.